Everybody, whoa, mic's on now. All right. So we're going to get started here. This is Brian Glas. He's going to do a talk on OWASP, and I'm sure it's going to be very exciting. So it's a great way to start the day, and enjoy.
You got it? There we go. All right. So we only have one mic on. That's good. Good morning, everybody. I know it's a little after 9, but, you know, that's why we have padding and schedules, is so that we don't end up with talks till 6. My name's Brian Glas. I work for a small AppSec consulting company called Invisium. I spent a lot of time working on OWASP stuff. Was one of the co-leads for SAM, and then in parallel, a co-lead for the OWASP Top 10. So today will be some of that story about last year. Who all has heard about the top 10 before? I'm hoping for a sizable percentage. Okay, good. The rest of you just haven't had enough coffee, or you're still staring at your phone. So I'm having a small competition with my colleague next door. So Kevin Cody, who just received the black badge, he talked me into submitting up here. He's like, you need to come up to B-Sides Pittsburgh. It's pretty awesome. So I had gone with him to B-Sides Knoxville because I'm from Chattanooga, so he was kind of in my territory, so I decided to try and come up to his territory. So we somehow ended up with dueling opening talks where he's got the other room and I've got this one. So I told him I was going to take a picture of everybody, and then we were going to count how many seats are left, because he said I had an unfair advantage because I had 150 seats and he only had 100. So I said, fine, we'll just count how many empty seats there are, and we'll see who was closer to capacity. So what I'm going to talk about today is there's a lot learned from dealing with the open data call with the OWASP Top 10. And unfortunately, only a tiny fraction of what you can learn from the data is actually in the Top 10 document itself. So I wanted to go through and try and help people understand some other information you can learn from that, because we ended up collecting one of the largest open public data sets about vulnerabilities found in applications that I've ever seen. And I'm not sure there's a bigger one than this set. So OWASP Top 10, how many people know it was actually released in 03? Much fewer hands. So most people know the top 10 as like a 3-year cycle, 04, 07, 10, 13. They were too busy on 16, so it bled into 17, and then all sorts of fun stuff started. But it actually started in 2003, and it was actually intended to be an annual document. And then when they went through the second revision, they're like, that's a little bit much. Let's push it out to about 3 years. So it's an awareness document. That's what its intent was, is basically at the start of AppSec, when it was really getting going in the early 2000s, people were like, what do I do? I just don't know where to start. And so Jeff Williams and Dave Wickers were like, let's give people 10 things to start with. Everyone likes a top 10 list, right? David Letterman's top 10, which I should add in here at some point, but haven't gotten around to it. So it's just awareness. And then it got added to PCI. And so awareness went to baseline. And then vendors were like, we need something that's measurable that people have heard of. And guess what? We're going to pick the top 10. And so now it's essentially the pseudo de facto sort of tongue-in-cheek standard of sorts. When the intent was that it's just for awareness, to help you understand where to start and not. I've heard people say, yeah, I have a whole AppSec program. It's the top 10. Like that's a fraction of an AppSec program. That is not a whole program. So like I said, the top 10 was supposed to go out in 2016. It didn't make it. It was a little bit busy. So in April of 2017, they released a release candidate. And I don't know, some of you probably remember, it depends if you were paying attention to Twitter or OWASP. There was a lot of backlash and controversy over the release candidate for the first round of the OWASP Top 10 2017. There were 2 new categories that were added. One was insufficient attack protection, and the other was underprotected APIs. Now, it's not that neither of them are actually a problem. It became more that the community backlashed against the way they got in and more the way they were written. Because A7 ended up being more written like, you need to buy a tool to solve this. And unfortunately, there was connections between the guys who wrote it and some tools they were selling, and I don't really know. I have no idea of intentions. I'm not passing judgment on intentions one way or the other. But social media, like social media likes to do, will absolutely pass judgment from everybody's individual phone and laptop and everything. So it got ugly. How many people followed that? Anybody? So this is new to you? Wow. I guess we live in our little like spheres of little chasms and such. But so I kind of got tired of this. I've got 4 kids. I try and insulate them from social media for a part. But I really got tired of the security community started tearing on each other. And they started tearing on OWASP over the whole thing. So I got tired of everybody just saying burn it to the ground, and nobody was trying to come up with anything constructive. So I wanted to do a little research because I feel like if I'm going to weigh in on anything, I need to have a background and I need to understand what's going on rather than just snapping off an opinion and then finding out that I'm wrong because I didn't know the story. So I reviewed the history of the top 10 development all the way back to 2003. And I was one of the people who didn't realize it started in 2003. But I found that the release candidate for every cycle didn't change between the release candidate and the final. For whatever discussions they were had, sometimes there was some discussion, sometimes not, it never changed. And so that became concerning on its own because at that point that said the process is whatever the release candidate came out with, it was basically going to be the same thing at the final. One year they flipped a couple of them around, but they didn't actually change what the categories were. So then because the data was all public, I decided to do some analysis of the data and see if it backed up what was in there, trying to figure out, get to the root of all of this. And then for better or worse, I wrote 2 blog posts on it. One was more about the process and trying to plead with people to stop just ripping into it and try and figure out something a little more constructive. And the second one is after I started digging into the data, I got way more curious about what was actually in the data. So the original data collection, they wanted full public attribution. They wanted it fully public. So that meant many contributors actually wouldn't contribute. At the time that the call went out for data, I was working at Microsoft's Trustworthy Computing. And I asked them, I'm like, hey, do you guys do anything with OWASP? And they're like, no, not really. Why? I'm like, you're Microsoft. We have like massive amounts of data. Can we share it? I'm like, yeah, you can try. So I talked with a bunch of internal teams, spent weeks on spreadsheets and calling out stuff for data. Had over 500,000 different findings that they had found and fixed before any of their apps ever being published. And then near the end, an exec's like, nope, can't release it. And like all it takes is one person to look at that data and write one blog about how horrible Microsoft is about security because they had 500,000 vulnerabilities that they found in their own stuff. And so unfortunately, that data never made it. I couldn't do anything about it. So what happens is when you do something at that full public level, the only people that contribute are consultants and vendors because they can bury the actual origins of the findings within their whole client base because it gets all aggregated together. You don't know which client those actually come from. So those end up being the only people who can really contribute. And that's one thing when we were working with the team, I was trying to plead with them that we need a better way to do that. We need some pseudo-public, some way to be able to contribute data with each other because right now everybody's learning stuff and then we don't get to share it with anybody. We relearn the same things over and over and over and it's ridiculous. So looking at the initial data set, I realized there's really 2 patterns. You have human augmented tools and tool augmented humans. They're a little awkward, but you know. So it comes down to frequency of findings. So if you look at, have you ever gotten a report that's generated off of a tool vendor versus a report off of a human pen tester? What's different about them? Everything. So when you ask a tool to find stuff, it tries to find every single specific instance of something and will report you every single specific instance of something. So you get hundreds and thousands of findings in a tool report. So when you get a report from a human, you get, hey, I found it 3 times, it's pretty pervasive. I can see that you have no control in your code or no control in the dynamic. This is a big problem, but I'm not going to find you every single one of them. So then there's context. Like, humans understand context, tools do not. So I worked at FedEx for about a decade as both developer and security. And we would run security tools against the code. And bless its heart, it was one of the better dynamic web scanners at the time. And almost every app, it would find a multitude of social security number exposures. Anybody want to hazard a guess why? So social security numbers are 9-digit numbers, right? So what else for a shipping company is a 9-digit number? Zip plus 4. Yes. So without knowing context, the tool has to say, I don't know, but it could be a social security number. It's 9 digits. So, but I can't tell you that it's like after a city state and therefore most likely a zip code. But a human will tell you that in a heartbeat. They'll know exactly that you're looking at a zip code. The other thing comes into it is natural curiosity. How many people have found a tool that's curious? It actually wanders around out of curiosity and says, hey, that looks weird. Let me poke that. Let me fuzz that. Let me put something else in there. Tools don't do that. They do exactly what you tell them to, sometimes. Most of the time, hopefully. They do exactly what a developer told them to, whether or not they realized they were telling them to do that. But on the other end of the scale, humans don't scale. The scalability, tools you can point at something and they will work 24/7. They will work for as much electricity or CPUs or disk space that you give them. Humans? Nope. We need a break. And then consistency. So as much as I hate to say this, if you get a pen test from the same company over and over and you get different people, they're going to find different things. Humans aren't consistent in that space. We all have patterns that we like to follow. We have different areas of expertise. But a tool, it should find the same thing over and over again in the same space. So one of the things, like I split up the data, and at the top you can look, there are you can see very clearly the average per app, the second to the last column, look at 212 findings per app. Do you think a human wrote that report? Like, no. Not 61, not 49. There's one in there at 17.3, but they identified themselves as being pure raw, untriaged output from a tool. That had nothing to do with humans. But then you get down to 15 and less, and that's definitely a sign that a human is doing it. And so that's where the tool augmented humans come into play. So I wanted to see, I'm like, all right, so we're playing with this. What are humans good at finding versus tooling? And so I broke it down. I was like, hey, of all of the findings that were identified, what are the machines good at finding versus the humans? And anything in orange-ish color, the humans were like 70% or better of the findings. Anything in gray, which is almost everything else, the tools were better at finding. But then I realized there's a small problem with looking at it that way, and that's frequency. Tools are finding a lot more, and the original data collected for the top 10 was based on frequency. So I said, all right, so looking at the top, the humans and machines are quite nicely, almost exactly 10-fold different. So I'm like, all right, let me just pretend for a minute. I got 10 times as many humans. And let me try and level the playing field and say, hey, we tested the same number of apps. It changes. All of a sudden, you realize the scalability problem, and humans are actually a decent bit better than tools still at finding stuff. We just don't have the time to find everything we need to find. We're writing way too much software, way too fast for the number of people to be able to find stuff in it. So all of a sudden, the chart flips, and you've got stuff that humans like almost exclusively find over tools, if you could scale them. So then we have the chart that I like to call the Pacman Effect. And that usually happens when you decide to make a pie chart with something, one single thing having at least 80-some%, and then you tilt it on the side so it looks like Pac-Man. The original data was very much overwhelmed by Veracode. Veracode was kind enough to submit data, but the thing was is their individual data submission comprised 90-some% of all of the initial data. And so whatever they found drowned everything else out at the time, especially on frequency. And guess what they found quite frequently? Cross-site scripting. What's been #1 on the top 10 for forever? Cross-site scripting. So I was curious, I'm like, so what happens if humans look at this? And it's a much more diverse lot when humans try and find stuff within an application. Actually, the interesting thing is cross-site scripting is #3. #1 is security misconfiguration, which we'll get to in a little bit to why that's actually an interesting setup. So I went through and I did these blog posts and talked with a few different people, and then have my one transition slide, because like my kids snuck SpongeBob into my deck. So has anybody heard of the OWASP Summit or the Open Security Summit? Okay. Is anybody active in OWASP right now? Not really. Interesting. Okay. So OWASP has, and they did it last year and they did it this year, they have a project summit that's like a dedicated separate summit. And it's a week in London, and essentially the projects get together and they just work on their projects. It's not a conference, there's not talks. You have working sessions all week. And yeah, honestly, we end up working 10, 12 hours for the day because we go all the way through dinner and such. But in June of 2017, I was heading there because I was one of the co-leads for SAM. And that's the software assurance maturity model. So if you're having to deal with program type stuff and you need to know where you're at, I highly recommend you take a look at SAM. But the top 10 leadership that's had it from '03 finally decided after 14 years, they're like, yeah, we're kind of done. This was just too much controversy. We're going to turn it over. And they turned it over to Andrew Vanderstock, who's been long-time OWASP. He's been board member. He's been working on the top 10. Really good guy. It was definitely a pleasure working with him. The top 10 had working sessions there because they were going to try and figure out what to do with the release candidate. So while I was there, they asked if I would help work on the top 10 because little did I know the data analysis I did for the blog post was more than anyone else had done on the data yet to date. So they're like, well, since you're so familiar with the data, can you help us do this part of the project? So while we were at the conference or at the summit, a new plan was put forward. And we basically said, look, our target is to release it by Thanksgiving of this year, but we have a boatload of work to do before then. And the data is not a lot, and we actually need it better. But we didn't disagree with the original intent of trying to have a couple of new categories within the top 10. Because if the top 10 was only ever built off of data, it's always looking back to a year or two, or maybe 3. So we're like, we might need some emerging categories, because they kind of did that with CSRF. In '07, Andrew added CSRF into the top 10 because from talking with other folks in the industry, they just knew everything was vulnerable to it. We had no defenses for it at that point. And it worked. It got attention, defenses got built. CSRF isn't what it used to be in terms of a risk. A lot of languages have stuff built in by default. The same site cookies are kicking in, and so CSRF isn't as much of a concern as it used to be. But we also changed it to have a fully open process in GitHub. So part of the process that the top 10 had was you just, every now and then the project would surface with some output, but there was no insight into who all was working on the team, who all was doing stuff, what decisions were being made, what was being discussed. So it was Andrew Vanderstock and Torsten Gigler and Neil. Oh, Neil's going to kill me because I can't remember his last name, standing up here under lights. Sorry, Neil. And myself. And then also being able to put it in the markdown in GitHub, it allowed, the OWASP top 10 is one of the most translated OWASP projects. And so it allowed groups to be able to actually actively translate it. So now we have like Spanish, French, Hebrew, Indonesian, Japanese, Korean. It's amazing. I've actually talked to a few folks from France, and they've basically said if you can't give their developers stuff written in French, they won't read it. They just won't pay attention to it. You can give them English stuff all day long, and they don't care. It's like if somebody translates it to French, then they'll read it. So we decided to get two forward-looking categories, we would open up a survey. It was mostly grassroots over Twitter and everything. We would do a survey. I have this slide because on day one of saying, hey, we're going to do a survey, we're going to survey the industry, everybody who can chime in, please do. Tell us, and we'll commit to having two of the categories into the top 10. Of course, somebody goes and asks within like 6 or 8 hours, hey, what happens if someone games the system? Like, thanks. That's so helpful. Now people are like, I wonder if I could game the system. So this slide's here to basically show, other than the like initial spike of, oh, this is interesting, maybe I'll spend time like filling out a survey of what I think is important coming up that's not touched in the top 10 yet. Pretty much all the other spikes in there are only when we went back and like retweeted again on Twitter and were like, hey, please fill out the survey. So there is no weird anomalous behavior in here. And to be honest, it would have been hard to game the system because you didn't know how many submissions there were. So you either ran the risk of being too low and not getting what you wanted, or being so ridiculously high that it was absolutely clear that somebody had gamed any particular answer. So when we were talking about this as a project, we were really hoping that we would have 100, 150 responses. We figured if we got to that point, we could at least say this was pretty good. We ended up with 550 people who were actually willing to go through and fill out the survey to do this influence. So the interesting thing so we did it in a ranked setup. Did anybody here fill out that survey? Just out of curiosity. Yes, thank you, by the way. At least one. So number one, and this is interesting, so exposure of private information, so privacy violations. So not really surprised. Cryptographic failures is number 2. So both of those fit really well into the sensitive data exposure. It was one that we already have. So within the top 10, each one is essentially a collection of different CWEs. Number 3 became deserialization. So that stood out on its own, so that became one of the categories that was added in 2017. Authorization bypass, essentially path traversal, insecure direct object reference. So that went into the broken access control. And then the 5th one on there was insufficient logging and monitoring, which I found to be quite fascinating that got identified as the number 5th most important. So that became A10. The one that in here that I have a feeling will only continue to grow is the one right in the middle, the inclusion of functionality from untrusted control sphere. It's essentially third-party code that you're integrating into your web app that you don't control. I mean, if you think about it, that should scare you in some respect, where there is the number of times you have site metrics, third-party ads, whatever. You basically let them put code in your app that says, hey, go pull code from some other server and embed it in the page. That's only going to get worse. And that's, from my perspective, that's something that I'm absolutely keeping an eye on because I expect that to go up further. It's not being abused like it could be yet, but I'm waiting for it. So one of the big things that we did when we reopened the data call is we switched from frequency to incidence rate. So like I said, we have a big problem of frequency. When you get data from tools and you get data from humans, you can't compare them, because tools will absolutely drown the humans when you look at frequency. So we looked at different ways that we could try and compare the two. And so we went into the space of epidemiology. So part of that's my dad's family practice. I grew up with all the large medical terms and everything. But incidence rate actually fit what we were doing. And that's really looking at how many apps had particular vulnerability types, at least one of. And so now if a tool finds cross-site scripting in an app, it's a 1. If a human finds it, it's a 1. They're now comparable. You now have whether or not that vulnerability existed in the app. You don't get the granularity of knowing, is this a systemic problem where you never actually designed for trying to defend against this vulnerability? Or is it like you had the framework and the developer goofed, or they purposefully turned off the control? You don't get that, but you do get the ability to go back and forth between a human and a tool. So Veracode was kind enough, they sent us 3 separate years worth of data. It's a ridiculous amount of data. Checkmarks chimed in. How many people know that Fortify is no longer HP? Just a few. So Fortify is actually Micro Focus now. Micro Focus last fall bought Fortify, ArcSight, and a few others from HP. So anyway, if you see Micro Focus, that's why. Synopsys contributed, BugCrowd contributed. They managed to get it under the wire at the last minute. They had a lot of discussion, and my hat's off to them because the bug hunting industry right now is incredibly competitive. And there is, whenever one of these vendors contributes this data, there is some risk to their business because that allows their competitors insight into some of this data that they wouldn't have had otherwise. So I cannot thank them enough for being willing to actually contribute. And my hope is it will actually get others to contribute and we can keep growing, doing more of this. We actually had data for over 114,000 applications tested, which is, to me, is just, it's astounding. So looking at incidence rate, so I'll try and blow this up a little bit. Notice something interesting. What's number 1 now? It's security misconfiguration. It's not cross-site scripting. It's not that cross-site scripting's totally dominated. All of a sudden, we have security misconfiguration. Happens in almost 25% of the apps tested in that data set. Cross-site scripting has almost the exact same incidence rate. Cryptographic issues, information leakage or disclosure, and then SQL injection. I mean, seriously, SQL injection. 10% of the apps tested still have SQL injection. How many years have we known how to not write bad SQL? It's been more than a decade. And we still have it in 10% of the apps. But you know why, right? Because sometimes we have to write queries that are too complicated for whatever structured setup we have built for a particular language. So in the names of backwards compatibility or still being able to do whatever we need to do with the data, we still get SQL injection. Unchecked redirect. XXEs were kind of surprised that they showed up all of a sudden. But looking at incidence rate, we all of a sudden had a very different view about what was actually showing up in applications. So all of this is public. You can find it in the OWASP GitHub if you want to play with it, if you want to challenge it, if you want to argue with me about it. That's fine. I don't mind. I'm not right all the time. I like to be. Just ask my kids. But I'm not. But it's interesting when you look at it this way. So I put in, these are the largest contributors. So I've got Micro Focus, Checkmarks, BugCrowd, 3 years of Veracode, Synopsys, Softtech. Anything in green means they found at least one. In one app, it showed up. Everything in white was nothing. So in that entire data set, they never found that vulnerability once in all the apps they tested. So what does that likely tell you? They didn't look. So one of the biggest challenges I've run into, and when I was working at Microsoft, so I wanted to work there because I was like, this is the beginning of the SDL. This is the company that started all of that. This is the company that owns the .NET framework. And so if anywhere you can actually fix security at the root, it would be there. So I wanted to go and learn all of that. And it was interesting because we had access to the guys who wrote .NET, who wrote COM objects, who wrote all that kind of stuff. Even in the Roslyn compiler, which is amazing now, they said one of the hardest things was to get these guys to write test cases. They said to write a good static analysis test case is exceedingly difficult. To actually understand the language well enough to know whether or not you actually have a problem at a particular point, they said we can't pay these guys enough to do it. They know how to do it, but it's just so painful to having how hard you have to think about it and how hard it is to get right, that is where part of the problem is we're just having a real problem getting people to write the right test cases to get the static analysis to do what it needs to do. So it's interesting. So if you look at like in check marks, and I'm not picking on anybody specifically, they're just easier to see from afar. In their data, authentication and security misconfigurations are both zeros. So basically, they'll never find that right now. Now I have to caveat this. This was the data set they sent me last year. They may have added tests to that since. And if you look at varicodes, so there's a very obvious one in the second row down. In 2014 and 2015 data, they have zeros. In 2016, all of a sudden, they have data. So somebody wrote test cases, and they started looking for security misconfigurations. Now, when they started looking, they found it in 44% of the apps that they tested that year, which tells me it's been there. It just wasn't looked for. And to have security configuration come out as the most prevalent at the incidence rate, and we haven't been looking for it in all of this, tells me there's even more of it out there. So it's interesting, because like sometimes, and it's interesting looking at the tools, some tools have more breadth than others. The other challenge with this is it's structured by CWEs. So putting all of this data together, companies store it differently. Some people will actually associate findings with CWEs, and some don't. So we ran into struggles like we even had, so anybody know HP's 7 Kingdoms? So HP, their guys decided that they weren't really crazy about how CWEs were structured. And to be honest, there's some challenges with CWEs. It's still one of the better things we have. I'd rather try and fix it than build yet another standard. Like y'all have seen the XKCD cartoon where they're like, we have 14 competing standards. Let's make the one standard to unite them all. And then the next frame, we have 15 competing standards to, it's like, stop making new ones. Let's fix what we have. So HP stores all of its data based on those 7 kingdoms that they do, not necessarily CWEs. So that's how fortified data is actually collected. So when I asked for it structured in CWEs, they had to go through and they had to go try and align what they had with CWEs. And we ran into some times where it's like your aggregation of all injections is actually a smaller number than SQL injection by itself. I don't think your aggregation worked quite right. And so they're like, nope, you're right. And they had to go back and they had to readjust it. So the biggest struggle we have is there's no standards for how we're doing this. CWE is the closest we can do at this point. But even with CWEs, the way they're laid out, you can have overlap. And you can have 3 really smart security people disagree which CWE a problem actually is. So let me ask real quick. I'm using CWEs as if I'm assuming you know what they mean. Does everybody know what a CWE is, generally? So you know what CVEs are, right? So CVEs is that common vulnerability enumeration. So you get the cool little number when you find a specific vulnerability in a specific piece of software. CWEs is abstracted a little bit. It's like a common weakness. And so it is more in general. It's not talking about a specific vulnerability that was found. It's talking about a vulnerability pattern, or more of a more architectural or more at a higher level. So, sorry, just sidetrack. I realized I forgot that. One other thing I wanted to do is I wanted to look at the data call results. And so I wanted to see what percentage of all of these people that submitted actually ever found a particular vulnerability in an app. So like like in their data. So like cross-site scripting is actually probably one of the easier things to find right now. At least one, right? So there is some cross-site scripting that you would have to fuzz for a long time to actually find some of them. But there is some dirt simple cross-site scripting. And quite honestly, it's like the most commonly used, a little pop-up alert box of hi or one or pwned or whatever. But also almost all of the vendors have found SQL injection or path traversal. or security misconfiguration, or crypto errors. But where we start to struggle is we start looking at insufficient anti-automation. Less than half of the vendors ever found it once in any app. Or XXE, or unvalidated forwards, or unrestricted upload of files. So, or insufficient security logging. At the very bottom, we have less than 20% of the people, of the vendors that submitted data ever found that once in that data. Not like I didn't find it in this app. They never found it once in their entire data set. So what can it tell us? It's like humans are still winning, right? I mean, if we weren't around, nobody'd tell the machines what to do, so I'm not surprised that humans find more diverse vulnerabilities. They just do. We're more creative in that space. Tools can find what they know to look for, and that's a challenge because it doesn't take much of a difference. I mean, look at AV and signature chasing and how hard it is to write signatures for every possible variant of a particular virus or worm or something. I mean, it doesn't take much to throw off checks. Tools can scale. They can scale really well at times. But then I run into the same problem where I'll do different talks about more about the SDL, and people are like, my static analysis scanner can't scale for my CI/CD setup. They're like, it's trying to run static analysis and it takes it 2 hours and I need it to be done in 2 minutes. I was like, there's no solution to that right now. Not at that scale. But from my perspective, we need both. We're not at the point where you can just do tools and no humans because you're going to miss a lot. But you can't do humans and no tools because you're going to miss a lot because you can only look at a small subset of applications. And honestly, we're not looking for everything. We just aren't. I mean, we're happily ignorant about a number of things because we don't have the time, we don't have the manpower to actually look for everything that's out there. The more languages we write, the more complicated we get, the more vulnerabilities we have we just don't know about. I mean, look how long deserialization was sitting out there before somebody realized you could do it in Java. And then the amazing thing was, look how long it took somebody to make that jump from Java to .NET. Microsoft sat there, because I was there, they were like, don't say anything about deserialization. They're like, because it exists in .NET, but nobody's made the connection yet, and we're fixing it. And they basically got it patched completely before somebody made the jump, and they're like, hey, wait a minute, what if .NET has the same deserialization problem? It was like a year between Java and .NET for talking about it. It was amazing. So what can the data not tell us? So right now, this is difficult because we don't store this. I work for a consultancy. We don't store this because it's too hard to actually capture this. Apps are so complicated and convoluted now. I'm looking at like 10, 12, 14 different programming languages within the same app. Trying to identify which language and version and framework that we actually found a vulnerability in to try and attribute to that is like ridiculously hard. So what I would love to know is I would love to know which language or framework is more susceptible to what types. We know there are certain frameworks that have more default controls in place where developers are less likely to run into a problem. But we have some that are far more susceptible. PHP is more susceptible to certain types of vulnerabilities than .NET. It's just the way the language of the framework is written. Our problem, like I said, incidence rate hides this. Our problem is systemic or one-off. That can make a really big difference because when you're looking at remediation or trying to fix something, it's a big difference between, oh, I goofed and I accidentally made this true instead of false, or I didn't use the right method here. It's a big difference in the time it takes to fix that versus the time it takes to re-architect something because you never even considered having to put that control in place. Is developer training effective? It's kind of a pet peeve to me. We're really good at testing developers by using multiple choice. Do you know what developers are really good at? Passing multiple choice. But it has zero bearing, almost zero bearing. There's going to be some, but almost zero bearing on how secure the code is at your company after the training. The problem is it takes a certain level of effort to actually understand that correlation between developers taking the class, let's look at the code they do over time beyond that class, do we see changes in what's introduced? Some of it is we just haven't built the infrastructure to do it, and some of it is there's some companies that are like, we're not going to play the blame game. We're not going to identify which developer actually did which vulnerability. Because I mean, wouldn't you kind of want to know at times, right? So I mean, not to single them out and fire them, be like, dude, you kind of keep writing some nasty dynamic SQL queries. Can we help you out with that? Maybe they got assigned all of the requirements for the nasty SQL stuff where they have no choice but to do that. Are IDE plugins effective? That's an interesting point, right? So if you get to a developer while they're in the mindset of writing code and you can say, hey, by the way, I don't think you really want to do that. Right then and there, they can fix that in like really quick, within a minute or two. If you wait till that gets published to production, and then you're like, hey, by the way, good job hashing everything with SHA-1, but the company standard is SHA-256. You're going to have to go back and change that. It's like, how much more time is it to go back, make that change, do the regression testing, revert a bunch of hashes or not, or migrate users of everything that was hashed versus at the moment of time of typing SHA-1, it says no. There's a huge difference in the amount of time that costs you to fix. The other thing I have no information on are how unique these findings are. They gave me a number of apps, and they gave me a number of findings in terms of incidents, but I have no idea how many apps are in there more than once. I don't know how often. I mean, because like in Veracode 74,000, I just don't know how many times the same app was retested over and over. I just don't have that level of granularity. The other thing, I had this fleeting thought, and now I've lost it. Oh, BugCrowd's data is fascinating. It was all human generated and human verified, right? So of all of the data set we had, of the ones that people claimed that they had verified and vetted and all of that jazz, BugCrowd's, people paid money for it because they paid out the bounty. This was all confirmed bounties that they paid. So this should be the most accurate data. Guess what I can't really get out of it? Incidence rate. Because incidence rate requires you knowing how many apps you tested. And BugCrowd's like, we can't tell you how many apps these people tested. We can only tell you what they reported on. We can't tell you what they tested. And so it became a different kind of a problem where you're like, this is my most accurate data set, but I don't know the scope. And so it's like, trying to do this with data is incredibly challenging. We're still seeing part of the picture, and that has to do with we're not testing everything. We don't really know what we're looking at half the time. So the numbers in this don't matter. I just used it to build a pattern because I wanted to show you this. So data in prod versus testing. So this is kind of something you would kind of want to expect to see. So you start where you're not looking. You're blissfully ignorant. You know stuff's there, but I just don't have the resources to deal with it, so I ain't going to look. So you start looking. So you get this really nice steep cliff. You implement some testing within your life cycle. And all of a sudden, you have this massive amount of vulnerabilities and technical debt and whatever people like to call it. So you get to work on it. You send people to training. You're getting a good steady decrease. Somebody bypasses the process. You get a little hiccup. That never happens, right? Nobody ever bypasses the process because, you know, some executive said, we need this out, and we're going to use this cool new tech. But also the other thing to note is it never actually hits zero. That's a fallacy. You will never run out of open vulnerabilities. If you do, you probably have one app and you haven't looked at everything. Just don't expect it. It needs to be manageable. I mean, we're in the business for security of managing risk, not eliminating risk. Eliminating risk is way too expensive for the business. And as much as it pains me to say as a security guy, every dollar spent on security is a dollar not spent on the business. So when you're looking at security, you better be darn sure you can sell them that this is worth the money that they're putting into it. So if you look at defects in testing, now notice I didn't call these vulnerabilities, I called these defects. Because these are things that have yet to be released. They're stuff you're finding and you're fixing before they ever get published. So you have a similar large climb and spike, but I expect you to sit more in the middle. And you're going to get spikes every time somebody introduces new languages, new frameworks, new dev teams, new apps, new something, right? it's not going to be a steady decline. It's going to do this. So be careful what you attempt to incentivize your developers for, or what you reward them for. Everybody remember the Dilbert cartoon where the pointy-haired boss goes up to Wally and says, hey, I'll give you $10 for every bug you find. Wally's like, sweet. And Dilbert comes back and he's like, what are you doing? He's like, I'm writing myself a new house. And he's writing a ton of bugs so he can find them all for $10 a pop. So be really careful what you incentivize developers for and testers for finding. But looking at structuring vulnerability data, look at what app is it related to? When did you find it? Language or framework? What point in the process you found? This is really important. Trying to figure out, did I find this when I was writing it? Did I find this in the initial test or in the build? Or did the third party that I'm required to do annual pen tests with find it for me later? Did my entire process fail? Or did I not even have a process to find this before it went to production? Like I've run into problems where like folks are like with DevOps, they're like, hey, we deploy 4 times a day. If there's a problem, we'll fix it like that. Like that's cool, but if you lost 4 million records out of your database, they don't come back like that. They're just gone. So knowing when in the process you find stuff really tells you where you need to be looking otherwise. Like if you only find it too late, try and see if you can find something earlier. The later you find any type of vulnerability, the more expensive it is to fix. And that's one of the things like, and it's, sorry, well, the next slide's good for soapboxing that. I'll wait. So again, with CVEs and CWEs, how many people know CWSS actually exists? Like 1, 2, okay. So CWSS is really cool. It's like CVSS, right? So your CVE gets a particular rating of severity based on all the known components related to it because you know of a specific instance within specific software. CWSS is its big brother. It's the same idea, but it's for common weaknesses. In many ways, I actually like CWSS better than CVSS. It's just nobody's ever heard of it. It's amazing. It's out there, and it's been out there for a while, but it was never really published. So one of the things I'm doing in my oodles of spare time with 4 kids and a consulting gig is trying to build some default CWSS scores for common CWEs, because they just don't exist. Nobody's actually gone through and written them yet. And then the last in the data structures is verified, especially if it comes from a tool. Did somebody come and verify it, or was it just found? Was it triaged? Did it really exist? So, I mean, when you look at different things, and like I said, each of the vendors gave me different stuff, and they looked different, and they smelled different, and we tried to structure them, but it's a challenge. It really is. And it's really hard to do data analysis without clean data. And that's one thing that a lot of times people won't say outside of like inner circles is without clean data, you're not going to get accurate analysis. You're going to end up with the wrong solutions and the wrong answers. So this is where I was going to get into a little for a minute. There's a difference between architectural flaws and bugs. So an architectural flaw is when you've messed up in the design. You either didn't put the control in the right place, or you didn't even put the control in place. Those, I've never seen anybody who can code their way out of a bad design. You just can't really do it. One of the stories Microsoft liked to tell when they first started implementing threat modeling is in Windows 7, they had a feature that like some admins had asked for, or at least voice of the customer people said admins had asked for. So they started threat modeling this feature, and they went through what all the controls need to be put in place to keep this feature from being abused. And by the time they were done, the only person who could actually use the feature or get any benefit out of it was the attacker. Because it was just something that never should be written. There was no way to protect it from malicious use. And so they cited that for a while because they're like, we just, through threat modeling, realized we cannot actually code this feature. And they're like, just think about what would have happened if we hadn't done it. We wrote the feature, we released it as part of Windows 7, and we had how many hundreds of million deploys and then found how bad this was and how badly it could be abused. So think about it. It doesn't require massive like days worth of work, but just every time you start to put a feature in, be like, if I wanted to abuse this feature, how could I abuse it? And what would I need to put in place that's reasonable to try and keep people from abusing this feature? Applying secure design principles. I was at a developer conference last week, and I asked them, I had a room of like 80 people, and like 80% of them were developers, and I said, how many of you know of a security standard that you're held against? Like, does your company have security standards? 6 hands raised out of 60-some people. I was like, if your dev teams don't know what's expected of them related to how to write secure software, you cannot expect them to write secure software. They're getting tested against something at the end of the day when a pen test that they never knew they were supposed to do. It's kind of like that nightmare, right? When you were a kid, you have that nightmare where you're sitting in class in your underwear and you're taking a test that you've never studied for. You don't know what you're looking at. And then if we start looking at data, it's like, what about training data? And I kind of hit on this a little bit before. It's like, how are you measuring training? Are you simply measuring it by attendance? Are you measuring it by like little multiple choice quizzes before and after? Or are you actually trying to correlate data from training with vulnerabilities found within your testing cycles? Can you create some link between them? Can you track it down to individual teams or individual people in terms of, you know, knowing where problems are? And like I said, it's not to like shame them or anything, but it's like certain people just may not grasp certain concepts. And that's fine. But would you not want to help them or be able to write more secure code? It's really about how you do it. But also, within your own data, do you know your top 10? Do you know what your dev teams struggle with in terms of vulnerabilities within your company? Not a global, super high level OWASP top 10, but down to their specific stuff. So what can you do? So, I mean, part of it is what story do you want to tell and what data is needed to tell that story. So if you're looking at a program or you're looking at trying to figure out, hey, I need some more help within security in a certain space, you need to build a story for that. And then you need to figure out what data needs to exist to tell that story. Do you want to tell how effective training is doing? Then you need to set up the infrastructure to be able to correlate findings from testing into matching up to what is going on with your training program. Structure your data and keep it clean. That is so dang hard. I mean, it is meat and potatoes. It is just grunt work. It's dirty in the trenches. But if that's not right, you're going to be telling your bosses the wrong things. You're going to make the wrong decisions. Oh, I think write stories was in there for security related stuff. When you write stories, when you're doing user stories, just think about it. I mean, there's a difference between writing a story of like, hey, users should be able to access their account and download a CSV, with users should be able to access only their own account or one they're authorized for and download CSV. There's a big difference between how you can code those two just by having a few different words in that sentence. Every now and then I'll have somebody ask me, like, is it better to have security sprints or is it better to have security built into each of the different stories? And in general, I'll tell you it's the second one. It's built into the stories. If you try, because this is what happens, and this is what used to happen in waterfall with testing. We're like, we can compress testing, it's fine. We need the features in place. We'll just shrink the testing time. I'm sure the devs did a good job at writing it. The same problem happens when you have security sprints, because they're like, oh, it's not functionality. Or you build a ton of functionality and then you decide, I'm going to do a security sprint to secure it. Guess what? It doesn't work well. You can't go back and tack it on later. It doesn't work. You can do security sprints like if you need to at the beginning build an authorization model, or you need to build authentication chunks, or you need to build some kind of common framework for security controls. That's fine. But that's functionality at that point, and it should be its own story. But like I said, in general, having that specific language in your stories makes all the difference in the world. And then if at all possible, try and figure out how to contribute to the top 10 2020. Like I said, I have the utmost respect for the companies who are willing to contribute. And I hope it only encourages more to do so. Because, I mean, our problem's way too complicated to solve in a ton of tiny silos. And we'll never actually get it right, or even come close to getting it right. The fun thing about security is we'll never solve the problem. We will only ever be playing catch up with the next tech. But we can start trying to be a little bit smarter about how we do it. And a lot of that has to do with being able to actually share with each other. There's a lot of people who are really afraid of what they perceive as airing dirty laundry. But to be honest, we've got to go somewhere and make some progress on that space. But that's what I had. So questions, thoughts? Yes.
Have you seen any open source documents or anything that you would reference as a great start to a security standard for a company?
Oh, open documents as a security standard?
Just anything that's just a great starting point other than here's a bunch of different rules.
So some of I've seen some people take like the OWASP ASVS because it's more the positive control side and use that to start trying to create standards. It's not part of this deck. I do more talks on SDLC type stuff. Standards should really be technology agnostic. So try and stay away from language specific stuff. That's a good question. I don't see a lot of it. There's a lot of companies that will make it and then they'll sell it. OWASP has some guidance, and there's some if you do a few Google searches, but there's nothing like totally stands out to me like this is the best starting point. It's a challenge, it really is. When I was at FedEx, it took us 4 months of meetings with the team of 6 of us to actually create the AppSec standards within FedEx. Question?
Yeah, your data collected, at least for the tool, is that specifically static scanning or some dynamic scanning?
So it was web apps, APIs, all that jazz, but it was static analysis, dynamic analysis, hybrid, humans doing both. Yeah, it had that full set in there.
Were they verified findings?
Yes and no. Some were and some weren't. Sometimes people were willing to give us enough of metadata to say, yes, we attest that these findings were verified, and sometimes not. So it's a challenge, right? So then how far is verified mean? But yeah, like I said, that's like hard part, to get clean data, to actually to understand what you're actually looking at. Yes? Sorry, I can't hear you. Security misconfigurations? Oh, so that's like, so most tools or most software, when you buy it, it's by the default configuration is just to get it to work, right? So you don't want to get your company around and support calls. So like LifeRay and a number of other like large portals or other things like that, they default to like all the services are on, all the ports are open, the usernames and passwords are defaults and easy to understand because it just needs to work or the customer's going to throw it away and not do anything with it. So misconfiguration is like S3 buckets that are public that shouldn't be, or you never hardened your software, or you never changed different configuration elements. It's that kind of thing. That make sense? Okay. Anything else? All right. Thank you.